All right, guys, so this is where we're picking up from yesterday because we finished the first problem, but we did not finish the rest of them. Yes?
Yep.
Hopefully these slides look a little bit better than they did yesterday. Would y'all say so? They're a little bit cleaner. I'm trying to get them all redone so that they actually look nice and they don't look just blurred. So this is the one we're looking at here. So this first one that we're doing today is, again, we're finding the equation of a line, interpreting the slope, and then kind of finding a calculation. For all the ones on the homework, you're not going to have to kind of do the last part here. The what is, okay, apparently. Try again. What is the balance after 36 payments? Because for the first so many problems, you're not going to have to do that part. We'll still do it here. We'll work through it here. But a lot of the ones on the homework, it's just going to be asking you to find the equation of a line and then interpret the slope. Tell us what the slope is telling us. Now for this here, the graph shows the remaining balance y on a car loan after making x monthly payments. Write an equation of the line and interpret the slope and y-intercept. What is the remaining balance after 36 payments? Okay, so the first thing we can do is find the slope. We need to find the slope of the line. Well, normally we use 2 points because we can use 2 points to find the slope. And slope is just rise over run. The change in y over the change in x is really all we're calculating when we calculate slope. Or when you take, if they'll decide to take calculus or above, they'll call it delta y over delta x. Which is just saying delta is just change, so the change in y over the change in x. So that's all it's talking about here. There we go. Now the y values for this here are what? So we can do 18 minus 15, or we could have done 15 minus 18. Whichever one we choose, we have to make the x values correspond to it. Since I chose 18 first, 0 minus 10. Now 18 minus 15 is? Yeah, well, it is 3, yes. 18 minus 15 would be a positive 3. 0 minus 10 is? So that is our slope. Now, the reason we say this is the slope is because 3 over 10 will reduce. That's as in simplest form as it gets. Now, are we surprised that the slope is negative? No, because the line is going where? Down. Because we're talking about the slope. We're talking about how the number of monthly payments is going to affect the balance, yes? If this was a positive slope, and this is actually what you're paying on your car loan, someone really tricks you bad. Because if you have a positive slope on what you're paying off on a car loan, that means you're increasing the balance of what you owe. You don't want to increase the balance on a car loan or any loan. You want it to go down. You want it to decrease. So this is our slope and the y-intercept. Now the y-intercept is 0, 18, yes? So what is the y-intercept telling us? That's what? In terms of this graph here. Right, it's talking about the balance. What balance? Right? Because what's the number of payments at the y-intercept? How many payments have we made? Because we owe 18, yes? And we've made 0. So that would be what? If we haven't made any payments, that would be? Well, 0, x is number of payments, yes? So at this point, how many payments have we made? 0. So what's the balance? So what does that tell us? If we haven't made any payments, Balance is 18,000. That's the starting balance. That's how much the car was worth, yes? So here the y-intercept is telling us the starting value of the car's worth. Car's worth, or I would say starting value. Or how much is originally owed. Because at this point, none of y'all have actually got a loan on a car. I would be safe in assuming that none of you have signed for a car loan. Whenever you sign for a car loan, y'all have heard of putting a down payment. Yes? So, if they say this person had put $4,000 on the down payment, the car's original worth is actually not $18,000. It's actually $22,000. Because your starting loan is actually not what the total car's worth, it's how much you owe on the car. So they would take whatever the down payment is off of your actual price and go from there. And if for some reason that you actually had the $18,000 on hand and the car's worth $18,000, I don't know how it is now, but it used to be, some dealership would do same as cash. Essentially, you would pretty much, I have the money to pay for the car now. We can do same as cash for 12 years, no interest, essentially, as if you bought it right then and there. And you could pay it to them for the next year. So then you make interest off of the $18,000 and not just spend it. But that's to each dealership. Now, if we interpret the slope, so we have -3 over 10. The 3 is talking about the balance in thousands, yes? And the 10 is payments. Well, we can't talk about the number of payments as a negative amount because number of payments is only going to go up. It's only positive, yes? So we could say for every 10 payments, the balance does what? Right, goes down or decreases by how much? $30,000. Are there different ways we could have phrased that? Yes. Because again, when we're interpreting the slope, we're just describing what the slope is telling us. Because I mean, we could have said go down, we could have said decreased. I mean, if we could have said that for every 5 payments, the balance goes down $1,500. I mean, there's different ways we could say it. Or the balance decreases by $3,000 for every 10 payments. Different ways we could phrase it. But as long as we're getting the same point across, that's what matters. Yes? All right. So let's look at what we've done so far. Write an equation of the line and interpret the slope. So have we interpreted the slope? Have we interpreted the y-intercept? Did we find the equation of the line? No. And what is the remaining balance after 36 months? So we have 2 parts left, yes? Now the general form for any equation, what we're trying to get to is y equals mx plus b, yes? That's what we want to get to for the equation of a line. It would be nice if we had the y-intercept, because if we have that, we already have half of it. Do we have the y-intercept? 18, because the y-intercept is always going to be the point. I'll write this up here, because y-intercept is always going to be 0, some value. That's the y-intercept. Because the y-intercept is where the x value is 0. So if we have that, we have the y-intercept. And for us here, the y-intercept is 0, 18. So the value of b is 18. Do we have the slope? Or -3 over 10 or -3/10. Okay? Do we have the equation of the line? Yeah, because if we have the y-intercept, we can plug that in and it makes it easier to work with. Now, if we hadn't noticed that, we could have still gotten to the same answer. We still could have gotten there. So 3 over negative 10 or negative 10 over 3, or 3 over negative 10. Yeah, no, they're the same. It's just where we're applying the negative. I like to put the negative on top just so we know what we're working with, or we can put it out front. Any questions on this here? Any question, everything we've done so far? Now we finished answering every part of the question. We got to find what? The remaining balance after 36 payments. At what? Yes. Okay, so where could we go from there? Well, the number of payments is X, yes? For 36 payments, I would plug 36 in for X, yes? Well, the only variable left is Y, isn't it? So on the one side, we have negative 3/10 times 36 plus 18. That whole sides are just numbers, isn't it? Could I plug all that into a calculator? Yeah. $7.42. So the remaining balance is? That's how much is left on the loan. We're halfway there. Any questions on any of this here? And it's good advice, don't take a car loan over 60 months. That's 5 years. I mean, that's about normal. Anything longer than this, then you run the risk of going upside down. Essentially, you owe more on the car than what it's worth. And the downside of that is if they totaled the car out, you still owe money on the car. So you're paying for a car you don't own anymore. Not a good thing. All right, we have 2 problems left and then we are done for today. We got 2 left. So we have this one and one more. Now when we look at this one here, we want the graph here shows the distance Allison hikes in X hours. Write an equation of the line and interpret the slope. How long does it take Allison to travel 14 miles? Traveling at the same rate. Well, the first thing we would really need to do is find the slope. And then we can find the equation. Did they give us 2 points? $24.5. So we can use 24.5 as our first y value minus the other y value, which is 0. So our starting x value is going to have to be 7 since we chose 24.5 first. Yep. Yes, make sure y is on top. Now, if we solve this here, we can't leave it. All right, guys, so we'll finish these 2 problems up here. They're not going to take that long. So any questions on this so far? Well, we can't leave the slope as 24.5 over 7. We have to have it as a fraction or a decimal. We can't have it as both. Now, luckily for us, the calculator can do this here. And this here works out to be, I believe, 3.5. You get the same thing, Lily? Yes. So that's our slope. Now, if we want to find the equation, we can use the y minus y1 equals m times x minus x1, our point slope form. Now, do we have the y-intercept? Yeah. And the y-intercept's value is what? 0. So if we're plugging it into point slope form, or slope intercept form, our slope is plus our y value of, our y-intercept is 0, yes? Do we need the plus 0? No. So the slope is just, or the equation is y equals 3.5x. And that's it. Questions on this here? Now, we need to interpret the slope. So we have 3.5, yes? We don't have it written, but it's understood to be kind of over 1. We're talking about 1 mile. Not 1 mile. We're talking about 1 hour. Because she's traveling what? 3.5 miles per hour, yes? So the slope is telling us in 1 hour, she travels what? .5 miles. No, you're good. If she could travel 14 miles in in 1 hour, that'd be impressive. So in 1 hour, she travels 3.5 miles. That's just interpreting the slope. Because we could have it as a fraction, that's 7/2. So for every 2 miles, or for every 7 miles, or for every 2 hours, she travels 7 miles. We can write it in different ways. Now, let's see here, what was it asking? So, write an equation, interpret the slope. We did that. How long does it take Allison to hike 14 miles? Traveling at the same rate. So we're trying to see where y is what? 14, yes? Now, we can do this and set y equal to 14 and solve. But we know in 1 hour she travels how far? So 1 hour, 3.5 miles. How about 2 hours? 3.5 plus 3.5 would be 7, yes? How about 3 hours? Four hours. So how long does it take her to travel 14 miles? And something like this here works nicely if the amount of time or what we're looking for is a nice number. Because if it had worked out to be, say, 3.5 miles, okay, we're going to have to do some more calculations. But that's it. Questions on any of this here? We ready for the next one? So the last problem we're looking at is this here. This is kind of modeling with equations, looking at two equations and kind of referring back and forth to them. How do they compare to each other? Now, two prom venues charge a rental fee plus a fee per student. So we have our starting value, our kind of y-intercept, and then our slope, because the amount that they're charging per student is going to be the slope. The table shows the cost, total cost for different number of students at Lakeside Inn. The total cost y in dollars for X students at Sunview Resort is represented by this equation. Which venue charges less per student? And how many students must attend for the total cost to be the same? So we're trying to find two things. We're trying to find which one's cheaper per student and how many students must attend for the total cost to be the same. Okay. So we have two questions that we're asking, that we're being asked. Well, for Sunview Resort, we already know how much they're charging per student, which is $10 per student. Now we just need to find out how much they're charging at Lakeside Inn, yes? Well, to find out that number, we just need to find the, what? Slope. So we could do 1500, because that's the y value over 100, minus, because y2 minus y1 over x2 minus x1. Over. So whenever we pick this to find the slope, we just needed to pick two of these sets of points. We just need to pick two. It didn't matter which ones we picked, because they will give us the same thing. Now 1500 minus 1800 is negative 300. 100 minus 125? Well, the negative and negative will make a. Now we just need to see how many times 25 goes into 300. So how much do they charge per student here? $12. Well, you're going about the right way, because we need the initial cost, because we're going to need that eventually. But for the first part, we don't, because we're just seeing which one's more expensive per student, or which one charges less per student, which would be Sunview Resort. Right. Now we are going to need to know the initial cost to be able to figure out which one of these, or at what point are they going to be the same. So really at this point, I mean, there's different ways we could go about it. We could start plugging in numbers. I can start plugging in these values of x into the other equation to see if they both had 100 students, will they have the same cost? If they both had 125 students, would they have the same cost? Or 150 or 175, 200, to see if I'm lucky enough for one of those to match up. The other way we could go about doing this is finding out what the equation for this lakeside inn would be. Now, do we know what the y-intercept is? No. But they did give us lots of points, yes? So we can use the y minus, well, yes. Multiply the 100. And then? Yes. And that would give us the y-intercept. Because, and we'll look at it here in a more mathematical, quote-unquote, mathematical sense, because that's 100% what we're doing. It's just not in the academic way, and so on and so forth. Because here, y1 is 1500. Our slope is 12, and x1 is 100. We'll have 12x. And as Wyatt, as you said, the first thing we would do is multiply 12 by 100, yes? What are we doing right here? 12 times 100. To get y by itself, we would add 1500, or really we're subtracting 1200 from 1500, telling us that we get 12x plus 300, or we're seeing that the initial cost, the y-intercept, is 300. Same exact thing, it's just not quote-unquote written in the mathematical way. Same exact thing. Because again, if you got to this equation without doing these steps, that's fine. Okay. Well, we have the two equations, yes? Because we have this one here, and Sunview was y equals 10x plus 600, yes? And we're wanting to see when these two have the same cost, yes? So we're wanting to see where the y values are the same. Well, if the y values are the same, it means that These here are going to be the same as well. So what we can do is set yes. Now we just need to solve for the value of x. So the first thing we can do is, yeah, either one. So we can subtract 10x, which will tell us that 2x plus 300 is equal to and lastly we would so how many students will make them be the same? Which one would be cheaper for if we had less than 150 students? Yes. Because the initial cost is less. This is where they're the same. So before 150, it's going to be looking at the initial cost. So Lakeview would be cheaper. After 150, which one would be cheaper? Sunview. Because even though they have a higher cost, starting cost, the lower number for the students, so eventually it will catch up. So depending on how many students you have, will depend on it. Now, if you have 150 that are supposed to show up, does it matter? No. If you have 160, is it really going to make that big of a difference? No. Let's see here. Because I actually do have this pulled up. So, actually, we're almost there. 290, 300. So at 300, you're looking at about $300 difference. I mean, 10, 20 students, it's really not going to make a huge difference because, again, at $300, you might start thinking one over the other. But again, if one has a better scenery, is a better overall quality, $300 is worth it. Because again, there's more to it than just a straight sticker price. Any questions on this here? We feel good with this? So, here we go. This is the last thing we'll talk about is line of best fit. Line of best fit, and I know this is blurry, is a line that lies as close as possible to all data points. Many technology tools have a linear regression feature that you can use to find the line of best fit for a set of data. The closer that there's a set R value that kind of tells us how reliable the data is, you don't have to fill this in. Don't fill it in. This is more for just your understanding. We can talk about the data being either close to 1 or -1. The closer it is to either one of those, the better the data is. And really anything that's outside of is between 1 and, what should be the other way around? Is between 0.95 and 1 or -1 and -0.95 is considered to be good data. If it's within 0.5, close to going to 1 or -1. It can't go above 1 or -1 because 1 or -1 means it's exactly to all the data points. If it's between those points of it, it's considered to be really good data. It's accurately modeling, the line's accurately modeling what we're looking at. Anything beyond this, it doesn't. If they give you something that has this R value of 0.5, that is terrible, or -0.5, because the closer to 0 means it is not modeling the data, or the equation doesn't model it at all in any way, shape, or form. But that's kind of line of best fit. And there's ways to go through using the calculator to find it. But we don't do it because depending on what data points you pick or what data or how it works with it, it kind of makes some of it vary. But this is your assignment here. So 3 through 9, find the equation of a line, verbally kind of explain the slope for 3 through 9. 11 is like the one we just did with the 2 prom venues. Okay, but I think it's going to be a newspaper. Talking about publishing an ad, the number of lines per page, so on and so forth.